Assalamu alaikum. In this lecture, we have to discuss about writing expression of the equilibrium constant. For this particular topic, first we have to consider a general equation or the general reaction is A plus B giving you the product. So first we have to write the Casey expression. So here we start. You have to write the product in the nominator side for the Casey expression. This is what is the product of this reaction. Then you have to place all the reactants involved in this particular reaction. These both are the reactants. Now you have to place for each of the reactant and the product or the square bracket. So a square bracket over here, this is the symbol of concentration. So this is what is called the Casey expression. Now over here, what we have used the Casey, that is what is the equilibrium constant. Now for the same reaction, now we have to discuss about the unit. That is what is the unit of the equilibrium constant. Considering the same equation, that is what is the A plus B giving you the product. First, as we know, the Casey expression is the concentration of P, what we have to pronounce with the square bracket, the product we have to pronounce the concentration of product in the denominator, the concentration of reactant A multiplied by concentration of reactant B. But we are now working for the unit for the Kc. So this is the unit of the Kc. So considering the same equation, we are copying it from here. So this is what is the concentration of the product. This is the concentration of reactant A, concentration of reactant B. So however, either it is reactant or the product, but that is the concentration. This is important for us. And as we know, the unit of concentration is mole per dm cube, or it should be represented by the capital M. So we now have to replace it by the capital M over here. Now one of the M is in the nominator side, and there is a M in the denominator side. So we may cancel it out to each other. So what remains over here is 1 over M. So this may be one of the unit for this particular reaction, or it may be written like the M inverse. So there's another representation for the unit of Kc for this particular reaction. Now considering another reaction, this is what is the esterification reaction. Over here, the acetic acid is one of the molecule is reacting with the ethyl alcohol, and these both are reacting and producing the ethyl acetate or the ester molecule plus water. We now have to write the Kc expression for this particular reaction. So we have to now write by the same method. First, we have to write both the products in the nominator side and both the reactants in the denominator side. So one by one, we have to place the reactants and the products. Now, as we have learned earlier, we have to place the square bracket for all the reactant and the product, and this is what is called the Kc expression. Now for the same esterification reaction, we now have to proceed for the unit of the Kc for this particular reaction. Here we are, this is the Kc expression. We now have to work for the unit of the Kc. So we now have to copy the same equation over here, and in place of the concentration of each of the product and the reactant, we have to replace it by the unit, that is what is the capital M. So here we are. Now we have to cancel out M is to 1 M. And this is once again the m should be cancelled. So there is a nothing remains. So whatever the unit, this should be having no unit. So for this particular reaction, the esterification, there is no unit for the Kc. Writing the expression of the equilibrium constant, we now have to consider the third reaction. This is the 3 moles of H2 is reacting with the 1 mole of N2 and giving you 2 moles of NH3. For the first time, we are using the number of moles more than 1. Over here, this is 2 and this is 3. So what we have to do now for writing the Kc expression for this reaction. So Kc, the same method, the product should be written uh, in the nominator side and the reactant should be written on the denominator side. And the same is over here. We have to place the square bracket for each of the product and the reactant. And now over here, the 3 is the number of moles for the hydrogen. It is mentioned by the red color. You now have to move this number as the power of that particular reactant, that is the H2. And then over here, the NH3, there are two moles of NH3, so that should be placed as a power of concentration of NH3. So this is the method of writing when there is more than 1 mole in any chemical reaction. So this is what is the Kc expression for the formation of NH3 by this reaction. Now we have to move for the unit of equilibrium considering the same equation. Now as we know, the Kc expression is same is written over here. And now you have to work for the unit of the Kc. This is what is the concentration of NH3. And we know the concentration of NH3 is m. So it should be m square. And the same is over here. The concentration of N2 is m. So it should be m powered by 3. And over here, this is the concentration of H2 is only m. So we have to now write like this. The m square in the denominator, m cube multiplied by m. Now we may write m cube by breaking it into m square multiplied by m. We have done this just to cancel it out, the m square by m square. Now what remains? This is 1 over m multiplied by m. So now we may write, it should be 1 over m square. So this is one of the unit for this particular reaction, or it may be written as m powered by -2. Thank you very much for watching.